Hi folks, Ms. Kalk here. I'm going to teach you about the Atomic Math Challenge. You have a choice on this assignment either to do the Atomic Math Challenge or to create your own song about atoms that tells what an atom is, the parts of the atom, and the charges of those subatomic particles. So here you see a box from the periodic table. Each box represents one element, which is one atom of that element. And elements are just all the things that we find in nature. So you see in the box 4 things. The top number is the atomic number. That number is equal to either the protons or the electrons. So for this atom being oxygen, it has the atomic number 8, which means it has 8 protons, and it also has 8 electrons. You see the symbol for oxygen is O, the name, and then at the bottom you have the atomic mass. Now, the atomic mass is the mass of the atom of the element oxygen. So this atom, oxygen, has a mass of 15.999. Now, that means that is how much matter is in one atom of that element. That on Earth will be the same as its weight, which you can find on the scale. But if you go anywhere other than Earth, say, for instance, the moon, the mass and the weight may not be the same. On the moon, the mass would be 15.999 because the oxygen wouldn't lose any matter, but it would weigh less because there's less gravity on the moon. Some periodic tables will actually round this number up, so you may actually see this represented as whole numbers. For instance, oxygen would be 16. So that number is the number of protons plus neutrons. And you'll see that down here at the bottom. The atomic mass is protons plus the neutrons. Okay, so let's take a look at how to do this atomic math challenge with that information now. Okay, so we are going to go to the next slide. Give me 1 second while I change to the pointer here. Okay, so we are going to do oxygen together. And then if you choose to do the Atomic Math Challenge as opposed to the song, you will do zinc, this Li, and the 3 on the next slide. So you will have 5 to do by yourself. Okay, so the first thing we do for these is we fill in what is missing on inside the box. So for here, the first one, what is missing is its name, oxygen. Okay, so we fill that information in first. You can always refer to the previous slide or this video if you get stuck on anything. The next thing we need to fill in is its atomic number. If you'll remember, that is the number at the top, which is 8. Okay, then we need the atomic mass, which is the number at the bottom, and that number is 15.999. For this assignment, if you will write the number that is actually in the box, do not round it. If your teacher were to have given you one that was already rounded, you would use that number. We are going to use the number that is given here. Now, we need to know the number of protons. If you'll remember, the number of protons is the atomic number, which is at the top. So that means that oxygen has 8 protons. It is also the number of electrons. So once again, that 8, the atomic number, is the number of electrons. Okay, now we need to find the number of neutrons. The number of neutrons is either the atomic mass minus the atomic number. Sorry about that. I'm trying to get that to go away. Or we could actually write it out as the numbers that are in the box, the atomic mass, which is 15.999 minus 8. Now you need to be careful that you are lining this up. That 8 is a whole number that goes under the 5. Remember, whole numbers have a decimal after them, and we can put zeros to hold our places here to help us with the math. You can also do this math on a calculator if that helps you. So you would plug in 15.999, hit the minus sign, and then hit 8 equals, and that's going to give you your answer. So if we do the math here, we get 999. And 15 minus 8 is 7. So that gives us 7.999 neutrons. Now, let me tell you a little something. You cannot have half of a neutron, just like you can't have half of a person. They either are a person or they're not there. So you can't have 0.999 neutrons. Okay, you can have 15.999 as its mass because that's how much matter's inside of it, and that's equivalent to its weight, but you can't have 0.999 neutrons. So you can round this up, but for this assignment, and since this is the first time you've done that, I would leave it alone. Don't do anything with it. Just write it as is. All right, folks, this is how you do the Atomic Math Challenge. If you have any questions, rewatch this video, pause it if necessary, as many times as you need to until you get it. All right, have a great day.